Good evening. My name is Scott Kennedy, and this is Security Science via Big Data. I am the security scientist for the cloud security team at Intuit, and this is
Eric Noggle. I'm the director of cloud security for Intuit. Just so you know which one's the scientist, he's the one in the lab coat, right? So thank you.
You're welcome.
Thank you for braving the end of the conference. What I've determined that this is a marathon, not a sprint, right? So being in the last session, when I saw that we were scheduled for the last session, definitely I commend all of you for taking time out. Even my colleagues from Intuit who are missing an opportunity to drink at the moment. So thank you all for coming. Our goals for this session are really, we want to talk, as the title would suggest, largely around the application of science and big data to the problem of information security. But it's just one part of an overall program that we call DevSecOps, right? And so I want to go through some of the details about that. But really want to introduce you very quickly to DevSecOps and where security science fits into that overall. At the cloud security team that I manage, we have a mission to basically get out of the way of our business, right? When I first started, we added a lot of friction. We were a traditional security shop where they were asking for permission, approvals, exceptions, other ways of basically moving into the cloud using traditional methods. We determined very quickly that it just wasn't going to move us fast enough as a company. And so basically we came up with the idea that we actually have to have an ability to move faster, automate, use our people, because we don't have infinite resources in the number of people that we're allowed to have on our staff. We need to actually automate as much as we can, and we need to embrace a new way of operating into the cloud. So one of the things that we want to do is to automate a lot of the things that we do. We want to have a difference in mentality, which is basically stop saying no, but basically lean in with the business to be able to tell them, you know, we will work with you on your biggest security problems, but we're saying go, right? Which is, you know, saying no is very easy for a security person. Saying yes or go is actually a very difficult thing to do. And it was a mindset shift for a lot of us on the team, and basically it allows us to move a lot faster. Why DevSecOps? Intuit was one of the keynotes last year at reInvent. Our CTO, Tayloe Stansberry, stood up and said in front of the world, we're all in on AWS. And what he meant by that is that we have decided that we're going to be moving all of our offers, right? TurboTax, QuickBooks, Quicken, all of those components Mint into the cloud. And we're on that journey. We are moving as quickly as we possibly can. We're even talking about different ways that we can accelerate that journey. But DevSecOps, the idea of security being able to keep up with the pace of business. If you think the best practice companies out there do 10 deployments a day, right? How does a security team that is a checklist-oriented environment keep up with that level of pace? You can certainly automate some of your tools and your security checking, but the ability to understand what's going on in the environment on a real-time basis requires automation. And it's not something that comes naturally to a lot of folks. So we built a team around the DevSecOps construct, which really was, you know, compliance operations, which is more traditional security, but security science, right? And that's mostly what this talk is about today, is the idea that we can use data and we can use the development of insights in order to be able to inform our decisions and frankly give us credibility in front of the business. So it's very important that we actually do our research. It's not just opinions, it's not fear, uncertainty, and doubt. It really is the idea of developing concrete data, doing experimentation, and basically pivoting fast. DevSecOps, it's really built on the Agile Foundation, the ability to understand that you don't understand exactly where the end is when you begin, right? It's the opposite of waterfall, obviously. But the idea is that, you know, we have a collection of security experts in our team, as I'm sure you do as well. We had the idea early on when I got there of developing and using our existing security talent and embedding them in individual development teams. One, we didn't have enough of them. Two, they had deep expertise in one or two areas, but not as security generalists across the cloud. So what we pulled them back into the central cloud security organization and basically made them part of a team so they could reinforce each other. and it allowed us to actually scale and build tooling that allowed us to move faster. One of the drivers for DevSecOps, as I mentioned, was the idea that embedding resources was a disaster, right? We just could not scale with the pace of the business transformation that was underway at Intuit. We needed the ability to move much faster. And we also needed different skill sets. So one of the best things we did early on, frankly, was hire a mix of people, as well as the people that were already there, people that actually have the ability to code. In this new environment, you have to have the ability to have security be code. And in order to do that, you have to have coders on staff. So we started with the concept that it's very difficult to hire the purple squirrels out there, right? One, they don't exist. A lot like unicorns. The idea is that we actually had to provide a training environment and a very good way of basically understanding what you need to operate in the environment and learn from each other and pivot quickly. So we couldn't keep up with the level of deployments that we're actually already undertaking in our environment. And so we had to automate tools. We actually had to build code to operate. The other thing that we did is that we basically took away all the crutches. We said in order to have security tooling, we actually have to build it in AWS exclusively. You can't have a VPN back into our data center. You can't consume any of our traditional resources. You have to figure out how to operate standalone in AWS. So that forced us to take security people, some of whom who had cloud content and context, and others that didn't, to develop very deep AWS expertise. The other thing is that traditional security operations doesn't apply to a lot of the security threats that you face in the cloud. Certainly traditional SIEMs, they absolutely do address a lot of the standard threats that exist in a data center. They also continue to exist in AWS. But a lot of the misconfiguration opportunities that AWS gives you, right? If anyone hasn't told you, AWS is not secure out of the box. Right? You actually have to do it right in order for it to be secure. If you do it right, you have the potential and actually the high likelihood of actually doing it better than you do in your existing data centers. But traditional security operations also needed to adapt. And as the topic of today, we needed far more data than we had in order to make good decisions in the cloud. CloudTrail alone is overwhelming if you don't have a way to parse it and to make sense of it. Tenets of DevSecOps. Customer-focused mindset, right? Identifying your customers is very, very, very important. So our customers are our product development teams, the teams that actually build the services that we deliver to the public. We needed to recognize that they are our customers, and we have to have the ability to view them as customers and what is useful for them, right? We don't want to be a friction point for them. We want to basically enable security as the least risky path and the best path for them to take, right? It's removing roadblocks. Otherwise, people will move around you, right? If you actually make it very difficult to consume or you get in their way, frankly, I was talking to someone in the hallway before, and people are surprised that people are using AWS in their environment when it's not approved yet. Shocking, right? That's what P cards are for, right? So from our standpoint, we recognize that people are going to the cloud whether we want them to or not. And into it, we want them to go. So we needed to provide a path of least resistance and a path of least friction for them to get there. Scale, 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 right? DevSecOps, it needs to have as a principle the ability to scale as the business moves. As the business moves in this environment, we actually have to be able to keep up with them. We have 1,400 accounts in the cloud today. That may be shocking to you if you haven't heard it from several of the other talks. If you have 2 or 3, we highly recommend that you actually embed the concept of blast radius in your thinking, right? So in your data center, hard outer shell, soft crunchy interior is the traditional theory of security. In the cloud, we have the potential to make it better by having individual containers, account boundaries, if you will. So we work very hard to make sure that all of the services that we consume do not actually violate those account boundaries. Objective criteria. Scott's going to talk more later in the presentation about scoring, right? One of the best things we did is an objective scoring criteria. Each team that is operating in the cloud gets an A through an F based on their efforts, right? And it's the same for everybody. So you may not like the criteria, you may not like the grading rubric, but everybody in the class has the same rubric. Right? That actually allowed us to move the needle a lot and got people to care about security. Proactive hunting, that's a great one. One of the best needle-moving things we've done at Intuit is actually having a red and blue team. Again, Scott will talk more about that. But a red team, obviously, attacking our own environment before someone else does. Blue team using the opportunity to see us attacking to improve our detection. And so basically, we mix team members between red and blue, and we actually use that to improve our environment. And obviously, a continuous detection, right? We need a 7x24 operations center to be able to understand what's happening in our environment. I would love to take a standpoint of protection, but the reality is detection is probably the best we're going to be able to do in a fast-moving environment. So detection is a must. Prevention is ideal. DevSecOps is really how we organize the team, right? Scott is actually the head of security science on our team. We have a compliance operations team that basically interfaces with our business to basically follow up on the things we find from the red teaming that's done in the security operations center. Security engineering is involved in building tooling across the environment. But one thing I want to say about the environment is that you begin with the end in mind, but you don't know exactly how you're going to get there, right? It really is an agile methodology to say, we know what we need to accomplish in the environment, we don't exactly know how. We pivot all the time. All of our sprints, basically, we have an idea of how it's going to end up, but the honest answer is that often it's different than what we thought at the beginning. So with that, I will turn it over to Scott.
Thank you. Good. I was going to say, can I get 41 minutes on the shot clock? One of the things in security science is a lot of times, especially in the security realms, we deal with fear, uncertainty, and doubt. Why do we have a firewall? Because a firewall vendor told us it was good. What does that mean? And a lot of times, people are spending a lot of money on a lot of things, but why are we doing the things that we're doing? And so the concept of security science is trying to change the ideas from FUD to fact. What can we prove? What can we mathematically show is happening? Can we establish a theory that training will help our users prevent them from being phished? All right, well, what sort of training do we need? What sort of metrics do we want to have to measure that fitness of our training? How do we verify that our people are being phished? What is the level of phishing that's going on? What's our baseline? Is animated training better or worse? I know it's funnier. I laughed, but does it actually work? So what sort of training actually is important? So if we run an exercise and run an experiment across our entire fleet and say, all right, here's training and we get 30% people phished. And then we run some better training and we get 60% people phished. Was it better or worse? I mean, if we have examples of what we want to actually measure and see whether or not it was effective. Now, in some cases, maybe you switched phishing vendors. Now, it's not an apples-to-apples comparison, it's an apples-to-bananas comparison. So in some cases, you got to be retesting and revising your assumptions again and again. But the whole basics of science is you have a question, like, how does gravity work? You have a hypothesis. There are strings we can't see pulling stuff down. An experiment, well, run a knife back and forth. Does an apple still fall? Oops, okay, well, what's a next theory? And so you go through this whole analyzing scenario, and we do it over. And the whole idea of security science is we want to answer simple questions. And for simple questions, I like going to, if you've seen me talk before, you've heard me say the same question. What is your password policy? All of us have one. It's like 15 characters, got to have at least 3 U's in it or whatever. Why is that your password policy? Is it doing what you expect? Is it working? I mean, we all have a password policy. How frequently do you change passwords? Well, Bob said it should be 93 days. Why? With 14-character passwords and 93-day password rotations, are you doing what you expected to do? Is it really protecting you, or is it annoying your users? With security science, the whole idea is we can start measuring that, and we can start providing some information. In the cloud, how frequently do you have to restack? It's an important question, because if you've got a policy where you're building machines by hand, and it takes you 92 days to get your database server up and running, but you have to rebuild it every 12 days, you're never going to get functional. You're going to be, hold on, I got to start again. And so can you start making decisions? Can you start leading your people down the right path? So one of the things we did, and this is from a previous examination we did, with our 90-day password length, or 90-day password policy, rotation, and the length of the password. If a attacker had $10,000, $10,000 isn't a lot of money. I mean, you can pull that together, buy a bunch of GPU cards, and then how fast can you crack the passwords you have? Well, if you're using MD5 passwords, I can crack 19 characters in under 90 days. I can go the entire key space. So if you have a 19-character password and I've got $10,000, if I capture your MD5 password file, I own you. Well, if you're using SHA-512, well, that's 11 characters. If you're using bcrypt, that's only 8 characters because I can't run my GPUs against it and I have to do a CPU-based attack and it completely changes my attacking method. Likewise, with the research we did with Red Hat Enterprise Linux, we were using RHEL 6 when we did this analysis. Comparing ourselves to the Amazon Red Hat and Enterprise RHEL 6 base server and our Intuit AMI, we can compare, and based on the frequency of CVSS vulnerabilities, which is from the MITRE group that are doing analysis, how frequently, if I wanted to keep a score below 4, would I have to restack? And that depends on the number of vulnerabilities. It depends on the number of packages you have installed. It depends on the number of libraries you have installed. If you've got PHP as part of your base image, how frequently does PHP have to get patched and all the PHP modules that are part of your base library? Now you have to, et cetera. And so with that, we found that we had to restack 5 to 10, 2 times less, whatever, half as much. There we go. Trying to do the math, it's not really easy when I'm... Science, yeah. Don't have a dyslexic do math, which is the other thing. Now, what we're doing with security science is we're using it as advocacy. How do we teach our people to do smart things? If they say, well, you guys always tell me I have to restack, but you don't tell me why. What do you mean I have to reboot? I don't want to change my password again. You know, every time we phish our users, we make them change their password. It's a hassle for them. If they understand why, if we go out and educate them, this is the problem, this is why it happens, you know, different nation-state attackers are doing this, people who want to get your credit card information are doing this. It's a constant battle, and they understand that, and you can show them the math behind it. It becomes a much easier sell. And when I say sell, I don't mean like FUD kind of sell, it's an explanation sell. They understand it because, ooh, this costs me how much more time? Time equals money, etc. It goes into education. If we can educate our users and give them tooling to help them make better decisions, then it reduces the overall threat to the company. And so the whole idea that we want to do is we give them tools, we give them education, and we get them to understand the problem. Instead of yelling at them every time they don't do something right, you teach them why it's not right and how to fix it themselves. And so it becomes a self-fulfilling prophecy. Now, one of the things we're doing is we're using some big data analytics to try and find these things. Because as we start looking around, how do we uncover these problems? I mean, it's really easy to say, okay, the password policy and restacking, that's easy. What's the next thing you've got to look at? How do you get there? With big data, we can start looking at all of the logs that are coming in, the CloudTrail logs, the application logs, the packet flows. We start looking at all of the sys logs from all of the systems. We start pulling all of this information together, and now you've got terabytes of information. That's great, but what are you going to do with it? So now you have to start analyzing it. And how do you analyze that level of data? How do you build these misuse cases? So one of the things that we start doing is we start focusing on that. And one of the things I like doing, and I call it hunt the wumpus, if you guys have ever visualized your data, you know, you draw graphs. One of the things I do is I graph the power usage of switches. And you can tell that by the amount of heat they produce on their chipsets and their fan speeds. And if you notice that 7 p.m. on Sunday night, all the fans of all your switches in your data centers go up, what's happening? You can look back at, you've suddenly got an anomaly. Now you've got a question you get to solve. And you're like, why does this happen? In some cases, it's because the cleaning people come in and they turn off the air conditioner so they can plug in their buffer. In other cases, you're actually using more information, more data, your servers are creating more heat, therefore the switches get hotter, etc. And the whole idea is with visualization, you suddenly see these spikes of information, these spikes of data come out. Humans are really good at figuring out patterns. We see patterns when they don't exist. I mean, we've all seen like Elvis on a piece of toast, right? The reason why we see that is because our mind is really good at seeing patterns that we can see in there. If you look in the pattern of the floor, there's like, well, I can see a woman's face and her hair going down. This is the way we normally see things. That's why we see the man on the moon. That's why we see all the random things that happen. The idea is using our brains to be able to use this. As we look at our data, we can see patterns that are going on, and then understanding why the reasons the patterns are there. So, as I like saying, we've got logs. And it's big, it's heavy, it's wood. Nobody remembers that, do they? Ren and Stimpy, come on. As of September, we have over 990 separate AWS accounts. We do this for something called blast radius. So that way, if one account gets compromised, we do not lose the entire corporation. We lose Bob's learning account, or we lose pre-prod for only one system. And that way, everything is separated. In fact, you have administrative separation as well. Just because you're an admin here doesn't mean you can do anything in this other account. And it lets you make ownership a tool for you. Because if you have your IT people own your AWS accounts, then who is responsible for the application server? Well, it's the IT people, because they own the account. Everything in the account's their responsibility. If, on the other hand, the application developer owns the application account, when they make a mistake, who gets yelled at? Not you. So I always like doing it that way. That way you don't have to be the person explaining to the board why somebody made a mistake, because in most cases, the IT security people are not the ones responsible for fixing it. They're the ones for saying, don't drive into the tree. Avoid the tree right in front of you. And somehow, when the car gets hits the tree, we get blamed. Because why didn't security tell us about the tree? Well, it was on page 947 of the documentation that said, don't hit trees. And so with all of these different accounts, the blast radius becomes really useful to us. And we're using Splunk currently. We're migrating in different methods, and Shannon talked about that earlier in her talk. And we also partner with third parties. We're using Mandiant FireEye as helping us in our SOC. They are providing wonderful resources to us, and they operate our 24/7 SOC. So they allow us to see information, and they're doing the real-time response, which is really nice. We ingest all our information, et cetera. So let's stop talking about logs. If you saw Shannon's talk, you saw a version of this slide. We're basically using our logs to profile drift. One of the things that goes on is we set standards. Standards like you must have a MFA for all of your admin accounts. So how do we measure that? How do we verify that people are doing it correctly? How do we ensure that we don't have an account that suddenly goes away from our standards? And so using automation, we can track this and we can alert on it. It becomes part of our operations. And as one of the things that Eric was saying, we have our different pillars. So you've got security science, which is the ones responsible for trying to find weird things. Then you've got security operations. They're the ones responsible for making people follow policy. So if there's a compliance issue, like you don't have MFA enabled, it's not you're hacked. It's you're not following policy. So it becomes a compliance operations issue. They get to work with the people, teach them, engage with them. And then you've got security operations. They're the ones that get called when, oh my God, we are being hacked. This is an incident. And then you've got security engineering, and they're the ones developing the tooling to allow the entire thing to work. Now, from a unified log, we have ability to see lots of different information. You can see in a single pane of glass everything that's going on. You can analyze in different ways what's happening. And so in some cases you can say like, okay, I'm getting more information from this server. Why is there a spike at this time? What's going on this specific day, et cetera. And you can see this information as you drill down in. Having that single pane of glass gives us the ability to know what's going on. It also lets us do some very interesting complex queries. As part of the complex queries, we can do things like pulling multiple sources of information together. For instance, one of the things that I think I've got a slide about this, but I'll talk about it now. One of the things that we have is in our MFA, I'm going to use that as an example, we have alerting that says somebody logged in that they didn't use MFA. Well, if you first create an IAM account, you don't have MFA because they have to log in and, step one, enable MFA. So if we use logging that says, all right, if you've logged in without MFA, and in the window that we're looking at, you then enabled MFA for your account, then don't worry about it because you're doing the right thing. Likewise, if you've logged in, enabled MFA, turned it off, turned it on, turned it off, turned it on, turned it off, well, you're in a default state of off at that window. Maybe we need to talk to you about why it's off. And so doing that analytics helps us find when we have problems. The other thing we're using is OpenDNS. Who here is using OpenDNS? You don't count. I saw like 1 or 2 hands. All right, 3 or 4 now. OpenDNS is very useful in being able to track, especially if you use it at home. It's great because you just can't get to bad things. Your DNS server will say, nope, I don't know where that website is. If you're using it in a corporation, you get all of that information filtered to you. So now you know that one of your servers is beaconing to a known bad host. This DNS name is known bad, and one of your servers doing it. Now you're getting information. OpenDNS didn't let it go out, but it gives you that information. So how do you mine that information where it's going on? Do you track and see, of all your DNS queries, who's talking to any of your banned countries? Who's talking to servers that in countries you really don't want them to? I mean, if you're doing work in the US military, you don't want to have .cn as one of the people you talk to. Unless, of course, you have a specific area that you say, okay, except for this one university that has this one program that we're working with. In doing that egress monitoring, you have the ability through OpenDNS to track what's going on. Now, if they're using IP addresses, changes the whole problem. But with a base level of DNS, you do have that information. So using that as a way of seeing that information is useful for you. Now, what about when you have an incident? What happens is you have, for instance, somebody has created a security group. And yes, I did a lot of blurring. So the idea is you see somebody create a security group. It's a 0.0.0.0. Nobody should have a 0.0.0 security group. See, I'm paranoid. I don't like people knowing my names and stuff. And so in here, we can see they created an SSH security group. We know what host that's on, what instance ID is connected to it. In fact, we've also done further drill down in this. It doesn't show up in this log if this is not a public IP. So that instance has a public IP, and it has a security group that is a 0.0 rule for port 22. So I know that somebody in my company has allowed a host to be connected from anywhere in the internet, which is against our policy. So this triggers an event for somebody to do compliance operations. They go talk to them and say, hey, why did you do this? It allows us to have this fleet of 990 plus accounts be able to be controlled by everyone else, but monitored and maintained by us. We also have, as I was saying, console login without MFA. Wow, that blurring is really cool looking. As you go in, you can see that somebody has gone in and used MFA in their CloudTrail logs, or they have not used MFA when they've done a console login. You now know what user you need to talk to. You can communicate with them and say, hey, I saw you log in at this time. What's going on? What's happening? You also have the ability to track and see what's using on in your chaos, or in our account, we call it chaos, what's going on with your admin rules. If somebody is using cross-account roles and they're using something that is a more aggressive role, We don't mind people doing get or list, especially in our admin role. But if somebody is doing a put or a create or a delete or an add, why did you just add a new user in this account? What are you doing this administrative role across accounts? It gives us the ability to catch when we are misusing our own tools. And in a lot of cases, we're doing actual good work, but we still want to have somebody look at this and figure out what's going on because we're doing something that's outside of our normal boundary. And when you combine this information together, you get to find interesting patterns. Now, what I mean by interesting patterns is, and here is SSH from non-Intuit IPs. When people are SSHing into our company, where do they come from? What IPs are they using? What users are they connecting into? This is going through all of our syslogs across all 900 accounts, being able to find out when people are doing what. So we can drill down and see that there are people in Seattle and people in San Jose SSHing in. Well, they didn't create a 0.0 rule. They created rules that allowed their home IP to come in. They actually were following policy, but also not following policy because we like to have people SSH in through our corporate IPs. So being able to track and see what happens and how frequently people are doing it gives us the ability to check. It also gives us the ability to find out when we start graphing it over time and over frequency, who is using it more frequently and who does it really, really interesting. The one I find interesting over here is that one outlier. Hold on, I'm going to beam right through Eric. Out in that far right corner, there's one account that goes to a few hosts 10,000 times. Why? This gets in the interesting. Somebody logging into a few hosts, they own a few, but one account going to 10,000 tries. Is that somebody trying to guess a password because they couldn't remember what it is? Or is it somebody doing a brute force of our password space? And that's actually what that was somebody had an open IP, they were brute forcing, just trying to guess and guess and guess and guess and guess. It shows up because it's very atypical. The other thing that we try to do with security science is we try to steer our PD teams or development teams to make sure that they do the right thing. One of what we do is we publish insights. Insights are basically articles, for lack of a better term, explaining the rationale behind our decisions. It's real easy for us to say, you must change your password every 90 days. And it's an arbitrary decision that nobody ever understands. If we then show them, based on the level of attacks that we see in our IDS logs, and based on the frequency of what our changes are, and based on the level of attacks that we've been seeing, and based on the amount of phishing attempts we get, and based on the cracking attacks by a $10,000 attacker, this is our sweet spot. People understand and they go, oh, I get it. If somebody told you you had to drive 55 miles an hour, and it was an arbitrary decision, would you just be happy with it? Would you be Sammy Hagar and write a song about why you can't drive the speed limit? Or would you start looking at, well, based on the speed limit, and actually we should be driving 63 miles an hour because the number of deaths in the United States on speeds, 63 is our sweet spot. Fewer people die at 63 miles an hour than they do at 55, or they do at 65. I don't know why you know that. Because it's these things that interest me. But the whole idea is, with these insights, you explain to the people the rationales behind your decisions. It's no longer arbitrary. They now understand at least where you're coming from. It also allows them not to be the people who go, well, I don't want to do it. Because when they understand the rationale behind the decision, they lose the ability to complain about it. Because now, well, I understand the rationale behind it, but I still don't like it, really isn't a defensible position for them. It also allows us to build tools to help them self-educate. I'll let you talk for a minute.
He's going to let me talk for a minute. I appreciate that. One of the things we do to actually talk to our PD teams and give them education is a portal, right? So they need to know how they're doing. This is something that we've put in place that allows teams to drill into their particular servers, their particular accounts, all the way drill down into the environment. It also allows them to get real-time training, right? So if you get a security score that says you are a D or an F or even a C. There's actually very concrete ways of basically saying, how do I improve my grade, right? So it's not fair to basically not give people the rubric. How do you get better, right? And so the idea of encouraging the best behaviors, basically give people information, allow them to make decisions. You can have people that say, I don't really care, excuse me, I don't really care about my grade. Excuse me. But the reality is that, we tell on them. So we talk to the senior leaders of the corporation, and we also ultimately have to report that to the board. So we don't really have a whole lot of problems with teams saying, I don't care about my grade. But we really want to actually encourage people to make their grade better. So we have Getting Started, we have Learn, we have tools that you can consume. We certainly have the ability to get customized reports. And then we also have senior leaders that want to know how they're doing across their fleet or all of their PD teams. So we give them the ability to see all of their environments, right? So, we in security have the ability to look across the entire fleet. Certainly individual ecosystems and the leaders in those spaces have the ability to look across their fleet, determine how they're doing, determine trending, determine how are we doing getting better.
And I'm sure that no other teams compare and contrast that their buddy who happens to be the EVP of this other team has a higher score than they do, and therefore, they have pressure.
What we found is that peer pressure works just as well as it did in high school, actually. So. One of the things that we wanted to talk about very quickly is the idea of security spending. This is something in my role that I actually get involved with quite a bit from the standpoint of how are we using our dollars and how can we use them most effectively. My thanks to Josh Corman. This is actually presented in his deck at the RSA Security event earlier this year. This tiny sliver you see in the middle is how much we spend on security software security, I should say. The reality of it, and it was presented in another slide, is the tip of the iceberg. The reality is that even in that space, what we spend on securing our software, we spend the majority of it on securing the software we write. But the reality is we subscribe to and utilize a whole bunch of open source frameworks for most of what we do. And that's actually where most of the Heartbleed, Ghost, all the different things that we've had to deal with across our fleet come into play. Right? And so those are often maintained by 3 guys and a dog, as we found out with a couple of these frameworks that we all rely on for really, really important parts of our infrastructure. So from our standpoint, we really are trying to focus on getting the PD teams through, this is just another example of science, right? Which is how are you spending your money? Are you actually being effective? The majority of the attacks that we've experienced, frankly, are software-based attacks. And they're not attacking the software we've written, even though that's where we're looking and where we're spending our money. It's on these open frameworks that basically we rely on quite strongly.
And so one of the reasons why scoring is critical is, grading is a wonderful motivator. And a lot of times when I'm having talks with our PD teams and they're like, well, how do I get an A? Well, you do these following actions. And how do I make sure I keep getting an A? And they ask, I want to always get an A. And I sort of ask the same question. It's like, when you were in 3rd grade, you had to do certain things to get an A, right? You don't do the same thing in 10th grade, right? You have to do more. Every day, you have to do a little bit more, because grading will get harder over time. And pretty soon, you're in college-level classes, and now you've got to figure out how to do calculus, and now and it keeps getting worse, because you have to keep getting better. Your grade is a reflection of how you're doing at this moment in time. So yes, you cannot guarantee that you will have an A forever, because at some point you will make a mistake, you will fail a test, you will forget to study, and you will have a problem. And so grading gives all of our people the ability to see what's going on in their system. It allows the PD leaders, as we were talking about, to drill down. Why am I failing? What's going on? Where am I using this why does this happen to me? So it lets you drill down and you can see, yep, I've got an F. Where do I have an F? Well, I've got an F when I'm using that one AMI. Okay, how do I find that information out? Well, I can drill down and take a look at the actual report and say, aha, this AMI has a failure because, let's see, what am I using in this one? Java. We don't have a Java problem. Okay, this one server, or this one AMI has an outdated Java. Now you know what your problem is, where to fix it, to get rid of that F. So you can now rebuild your servers and restack and get away from that F. You can just say, oh, sorry, I have to update to the new AMI. I'm done. Boom, you're solved. It also lets you take a look at all the instances. What instances are using that AMI? I know I've gotten a failing grade, but where do I need to do the work? So how do I find this out? And I only have a couple hosts to fix it on this. The next thing in AMI and scoring is being able to prevent this going forward. So if you have the problem where you have a failing grade because you keep having to patch and you find out after the fact, is there a way that you can model this going in the future? Saying, all right, if I restack every 10 days, will that guarantee I don't have an F? Well, maybe, but how do you know? With CVSS modeling, you can give the PD teams the ability, I always say public domain when I say PD, the teams the ability to model their own usage and say, all right, I have a choice. Should I use Python or PHP? That decision takes you down an entirely different path. If you're using PHP, what libraries and what modules do you have to have in your PHP environment? How frequently do they have problems? How frequently are they updated? What's the update reliability of those? How often do they have a CVSS problem, et cetera, et cetera, et cetera. Python, you have the same problem going in a different manner. If you put both on your system because you haven't made the decision yet, well, then you've got twice the vulnerability because you have to maintain both sets of operating systems, both sets of applications, all of the issues all at once. What database do you want to use? Postfix, MySQL, same problem. As you go down, Apache Nginx, as you go down, it's always the same decisions. So how do we allow people to model ahead of time? Over the summer, we had one of our interns work on a scoring tool. He developed the tool that lets you say, all right, here's the list of RPMs that I'm going to be using, or I'm thinking of using. Let me load it in here, and let me compare the last 2. No, let's make it last 3 years. And I want to make a decision that if I have a score below a CVSS of 4, which is currently where we've chosen to put an F, if you have a vulnerability that is ranked in the CVSS-based score of 4 and higher, that's an immediate F because you have a vulnerability that is significant. Below that, you can fix it later. But above 4, you have a problem. So how do I do that? I load up, and I suddenly find out that based off the packages I installed on the 2013 to 2015, I will have to restack every 6.77 days because there's 145 vulnerabilities in the CVSS library, which is oval, that tells me how frequently I'll have a problem. Now, as you know, every time we see any of the financial advice commercials, past performance is no indication of future performance. It's not telling you that you will have to restack every 6.77 days. What it's saying is based on 2013 to 2015, the frequency over that 2-year window, given your choice, is 6.77 days. So did they work really, really, really hard one day and just fixed all of their vulnerabilities and released 16,000 patches? Well, that would skew your data. But you also have the ability to drill down and see which one is going on. We're also looking at how do we provide other tooling. How do I know when I need to rekey? How frequently should I be rekeying my information? If the policy says I have to rekey every 90 or 180 or 365 days, but I rekey every 45 days because I want to be proactive, is that good enough? Or is it costing me too much money? So that the re-encryption speed, the re-encryption cost versus the key tempo of how frequently you rekey. These are decisions that we can do modeling for to help our people to be able to make better decisions. Likewise, what encryption algorithm should I use? Can I use SHA-256 CBC? Or should I use SHA-256 EBA? Or should I use bcrypt? Well, there's not a lot of libraries for it, but it's really secure. I mean, these decisions are important for a PD team to make the right decision when they're protecting information. Go ahead. Okay. Based on our shot clock, we've got about 15 minutes left. So from a wrap-up perspective, the DevSecOps organization, which there's a lot of us here already, we have a community that's on LinkedIn, Twitter, GitHub, as well as devsecops.org. If you would be interested in knowing more about this, we encourage you to join. We encourage you to participate. We do something called open contribution. We want you to take our code, complain about it, submit pull requests saying your stuff sucked and here's how I think it should be better. You sending back in your fixes and your changes to our code makes us better. It also makes you better. It also lets you start the conversation of, hey, I want to change what you're doing in a different way, and let me explain why. And so being part of the DevSecOps organization, movement, community, however you want to phrase it, allows you to be able to help your own people perform better. And if you're looking at how do you do a cloud security strategy, if you take a look at all of what you're doing in your cloud security organization or all you're doing in your cloud migration path, you start with what is our strategy? What are we moving to the cloud? And you start working your way backwards and saying, all right, well, if I'm moving everything to the cloud, then how am I going to put security requirements around that? What products am I going to use around that? And as you work your way back, you basically try to make this a simpler problem. Because if you look at it from a high-level perspective, you have way too much to work on. Any questions? Click. Oh. Yeah. Those are talks that have already happened. So if you didn't get a chance to see them, I suggest you go to YouTube. And if you do have a question, we do have a microphone up front here in the huge room, so that you're also on recording when you ask the question. So, and complete your evaluations, and don't forget to go to the party tonight.